In this video, we're going to factor algebraic expressions to write them in an equivalent form. So when I look at number 1, I see two terms, and I see 49 and 7, and I think to myself, 7 goes into both of those, because I know that 7 goes into 49, and 7 clearly goes into 7. And there isn't anything bigger than 7 that would go into each. So I'm going to factor out a 7. That's the language I would use. So when I say factor out, I'm talking about dividing each term by 7. So 49w, if I divide it by 7, I would get 7w. There's a minus sign here. And then 7 divided by 7 is 1. And you can check. I'm going to go over here and check. The nice thing about factoring is that it's actually quite easy to multiply back out. 7 times 7w minus 1. If I were to multiply these, I would distribute, and I would get 49w minus 7, which is exactly what I started with. So my check works. Okay, factoring this one, w squared plus 17w plus 70, it's going to take a little more thinking. So I'm going to go down here and I'm going to take over some space, and we are going to solve, we're going to look at this problem. Let me make it smaller. So this is an unrelated problem, but it turns out it's actually very related. So this is just an example that we need to help our thinking. Okay, this is an example where we took 3x minus 1 times 4x minus 2, and we got 12x squared minus 10x plus 2. This is multiplying out. So the question is, if I had started with 12x squared minus 10x plus 2, could I have worked backwards to figure out, let me change colors again, could I have worked backwards to figure out what was multiplied in the first place? Could I have gone in this direction? Instead of multiplying these two and getting my result, could I have started with a result and worked backwards? So in order to answer that question, what we need to do is we need to look at some patterns. As I look at this, the first thing I notice is that 3x times 4x is 12x squared. That seems to work, that these two numbers multiply to 12. So that something's always going to happen there. And then these last two numbers multiply to 2. It's these middle two numbers that are going to be harder to find. So here's another pattern that we can observe. Every single time you make a problem like this and you structure it with this rectangle, look at 12x squared times 2. If I multiply that, 12x squared times 2 is 24x squared. And then, so I call that the diagonal. And then look at this diagonal. Negative 4x times negative 6x. Well, negative times negative is positive, and x times x is x squared. So this is also 24x squared. So my diagonals have the same product. And if you look, there's the 12x squared and the 2. That's where I get the 24 from, the 24x squared. If I take the first term and the last term and multiply them, I get my 24x squared. So that's one observation. Then the other observation, I'll change colors again. This middle term, negative 10x, it's the sum of these two. Negative 6x plus negative 4x is negative 10x. So this is the sum, and the other two were the product of the diagonals. So this is a pattern. Think of it like a puzzle. I'm going to go up to the top now, and we're going to do the one we just started with. Go back and find it. Okay, so we're going to use those patterns, and we're going to figure this out. So I'm going to draw my box. And I know my diagonals are going to have a certain product, and it's going to be w squared times 70. So I'm going to have 70w squared on this diagonal, and 70w squared on this diagonal, the products. Something else to observe from our example down here is that, see that how the 12x squared is the first box and the 2 is the other box? That happens every single time. Whatever the first term goes here, the last term goes here. So I can apply that up here. I can just immediately put the first term, so w squared, goes in the first box, and the 70 goes in the last box. The real question is, what are these? Well, I know that that is 70w squared, because that's my diagonal, so this diagonal has to multiply to 70w squared. So I immediately, my brain starts spinning 70. Okay, that could be 7 times 10, and then, aha! 7 times 10 is 70, and 7 plus 10 is 17. So I can do 7w and 10w. Those add to 17, and they multiply to 70. So now all I have to do is go back and figure out what would go on the outside of this box. So w squared is w times w. That would give me w squared. And then this right here, whatever it is, something times w is 7w, so this must be a 7. And I'm going to put a plus to show that it's positive. Something times w would be 10w, so this must be a 10. And again, I'm going to make it positive. So that's factored. I have w plus 7 and w plus 10. And you can check. If you multiply it back out, you get what you started with. Number 3 is the same. So let's do number 4, and then we'll call it done. Go back. Start at the beginning here. My first term, 2x squared, goes in the first box, and minus 3 goes in the second box, or the last box. And that has a product of negative 6x squared. So whatever those two blanks are, they're also negative 6x squared. So now I have to start thinking of things that multiply to negative 6, but add to 1. They have to add to 1. So 6 is going to be 2 times 3. So what if I had a 3x and a minus 2x? Those 3 plus negative 2 is 1. They add to 1, and they multiply to negative 6. So we've got it. Okay, so now all I have to do is figure out what the outside is. 2x squared has to be 2x times x. But how did I know where to put those? So one thing that I always look at is if you look at this column right here, 2x and minus 2x, both of those are divisible by 2, so I put the 2x here. And you'll find that it almost always works out that way. So 2x times x is 2x squared. If I put a 3 here, x times 3 is 3x. And 2x times negative 1 would be minus 2x. And then you can check, negative 1 times 3 is negative 3. So finally I'm done. My factored form is going to be 2x plus 3 times x minus 1. And those are factored. We went from a sum of 3 terms to a product.